So today we're going to learn several methods of factoring. Okay. Unlike last time or other sections, analyses, they tell you which method to use, right? Kind of, right? They either tell you use the difference of square, use the ax squared plus bx plus c form, and also, all that stuff. But guess what's going to happen in this section? They don't tell you anything. All they say is factor, that's all. But we know how to do all that stuff. So that's what we're going to learn. Any question? Does that make sense? So before we get to that, let me explain to you what really factoring completely means, right? When I say factor, you need to factor completely. Just like when you simplify, you want to simplify completely, right? So write this down. Polynomial is factored completely when, anybody know how we define this or how we describe something that's some polynomial that is factored completely? Any idea? A polynomial is factored completely when, yeah. No, not just, you don't have to have binomial. Sometimes you could have monomial. Right? Yeah, what do you think? When everything is prime, it's exactly right. What do you mean by when everything is prime? What are? Yeah, you can't factor any further. So this is how I describe it. So I wrote this way. When it is expressed as the product of a monomial and one or more prime, that's the key, prime polynomials. We don't want any polynomial. We want the polynomial that is prime, right? Then you have factor completely. Okay, write this down. Let's try an example. Let's factor completely. So something like this. 9ay squared minus 4a. Okay. So what do you think I should do first, by the way? Whenever you have things to factor, you should look for something first. Sophia? GCF is correct. What is my GCF in this? Laura? Negative 1a? Negative 1a? Why negative 1a? Isn't it just a? Because if you factor out a negative 1a, then the first term becomes negative. We don't want the first term to be negative, right? So let's factor out a. Factor out an a. Who can tell me what to write when I factor out an a? Two people? What? Where? Huh? Oh, okay. Yeah, how about Kristen? Good. A times 9y squared minus 4. You guys remember this? We learned this long time ago. We call this distributive property backwards, right? Because if you don't believe me, go ahead and distribute that a, right? Don't you get the same expression? We're done, right? No, because we said we have to factor completely. Look at the binomial inside. It is actually factorable, isn't it? Shrek?
A times 3y minus 2 times 3y minus 2.
Excellent. And now before you do that, I actually write this step. Watch this. Do you see how I do this so that I don't mess up? Why do you think this simple step is helpful? Why do you think it's a good idea? Even though you have to write one more step, why is this nice to write? Yeah, Derek?
So you don't accidentally write the wrong.
That's right. So you don't actually write the wrong A and B. If you write it in this form, right, you can see your A is 3y, your B is 2. Otherwise, you really easy to make mistake, right? People might write, instead of 3y, they might write 9y or something like that, right? Instead of 2, they write 4. Yeah, question? What happens to y squared? Yeah, 3y times 3y is not 9y squared. Okay, good. So, Marilyn, can you tell me what I get? Even though Shrek said it. Is it 3y squared? What's your A? Your A is 3y. What's your B? So remember, difference of square, if you have a squared minus b squared, is a plus b times a minus b. It's not a squared minus b, right? So can you tell me what it is again? You got it. That's right. Now, can I go any further? No. Look at all my polynomials, right? They're all primes. We can't factor any further. Now you're done factoring. Are we okay with that? You good? Good. Pretty straightforward. So today I'm going to give you some examples, that you might see for your homework. We're not going to tell you which method to use. You need to choose, okay? You need to choose the right method. Good. Go ahead, everybody try example 2. This is very similar to the one we just had before. Think about how you go about factoring this, okay? Go ahead, everybody try. Yeah, okay, here we go. Example 2. What's my GCF? Christine. Negative 2x squared. I think that's a good idea. Why not positive 2x squared? Why negative 2x squared? You know what I mean? Like, couldn't you just... Why negative... Sophia, why? Yeah. Don't you want... So, you want the... Which term, especially? Not the... You don't have to have everything all positive. But which term do we want this to be? Laura? We want the first term to be positive, right? If this was positive 2x to the fourth, I would have just factored out positive 2x squared. You know what I mean? But since this was negative, But it's kind of nice. The whole thing, everything turns positive. But really, I'm mainly looking at the first term when you write this in standard form, right? Because that's easier to factor. You see what I mean? All right, so I'm done, right? No. Oh, okay. You're right. So look at the trinomial. Is this trinomial factorable? Derek? Only one person knows? Derek is the only one? Anybody else? How about... yeah, how about here? That's right. This happens to be, do you guys remember what this trinomial is called? This is a special type. Yeah. It's perfect square trinomial. But nevertheless, it's that form, right? 1x squared plus bx plus c, right? So I could do this. If you didn't see it was perfect square trinomial, you could always factor this out this way. Okay, so the answer, I wrote it this way. Negative 2x squared times x plus 3 squared. Is that okay? Is that good enough? Could I go any further?
No.
No. Okay, that's it. Questions? How many people got it right? Raise your hand. If you didn't, do you see how to get it right now? Yes? Okay, try this then, the next one. Alright, if you got example 2, right? Try example 3, it's very similar. So as a matter of fact, I think it's easier. Yeah, go ahead. It's sorry, yeah. It's 6n cubed minus 21n squared minus 45n. Okay, go ahead, everybody try. Alright, so what is my first step? Elizabeth, what did you do first here? Oh, there's GCF, huh? What's GCF for this trinomial? 3n. Would you all agree?
Yeah.
Would you factor out a negative 3n? No, then it makes the, just 2n is perfect because first term is positive anyway. So, yeah, you only want to factor out a negative if the first term is negative, right? Question? Oh, there you go. Is that better? Sorry. Then, how many, okay, look at the trinomial. We have to check and see if that trinomial is factorable. If it's not, you're done. If it is, then you should factor. Now, how many ways are there to get 2n squared? One way. 2n n? N. And 15, how many ways are there for 15? 1, 15, 3, 5. Okay, but one of them has to be what? Negative, because you have negative 15. Which one works? Anybody? 1, 2, 3. At this point, you see how it's fast? In the very beginning of this section, it took a long time, right? Now, I think a lot of you see it a lot faster. 1, 2, 3, 4, okay? Okay, go ahead, Shroud.
Okay, I got 2n minus 3 times n plus 5.
Do you agree? 2n minus 3 times n plus 5?
No.
Uh-oh.
No, man.
Okay, uh-oh. Harrison, what'd you put?
This one, 2n plus 3 times n plus 5.
Okay. How many people agree with Harrison? Okay, a lot more people. Shroud, be careful, right? Don't you need negative 5 here? That means you didn't check. Okay, guys, those of you that did not get the right, did not factor this correctly, that means you didn't check, right? You got to check. 2n times 2n, of course, you get 2n squared. What's 2n times negative 5? Negative 10. Don't we want negative 7n?
Oh, it's
And then,
minus
yeah.
7.
And then here, we want to get n times 3, you get positive 3. See how it checks? You got to check. Otherwise, you're going to get it wrong. So, Shreya, what's the answer then?
Okay, I got 3n. So I got 3n times 2n plus 5.
Oh, it's not 2n plus 5. Shreya, look at what we got here.
Oh yeah, plus 3.
Plus 3 times
N minus 5.
n minus 5. Okay? Be careful, right? You should always be checking these, right? If you're checking these, you shouldn't get these wrong. Any question? We good? Shall we try example 4? All right, example 4. This is a little bit more interesting. So far, it's been all kind of similar. Check out this example 4, okay? Go ahead. Example 4. X cubed y minus xy plus 5x squared y minus 5y is example 4. Now, how is this one a little bit different than the rest of them? Anais? It's not a trinomial anymore, right? So what are you going to do? Remember, if it's not a trinomial, you have two choices. Either you group them by 2's or you group them by 3's. But before you do any grouping, do you think you should always look for GCF regardless?
Yeah.
Yes. Okay, go ahead. Everybody try. All right. Who could tell me what to do first? A little different. Savannah, what did you do first here? Oh, you grouped them first? You don't want to factor out your GCF first? Oh, it works that way too, but then let's just kind of be consistent, right? If you see a GCF, why don't we just factor it out, right? What is my GCF? Owen? Why? Isn't that my GCF? Right? Let's just factor that out first. You know, that's what we've been doing all this time. Now, then you can group them. So Savannah, how would you like to group them? By 2's or 3's? Choose. Why don't we want to group them by 3's? Because when do we want to group them by 3's, guys? Raise your hand. Yeah. When you see perfect square trinomial, that's what, right? Do you see any perfect square trinomials in here? No, there isn't any. Okay, so you group them by 2's. Which, how? Like first 2, last 2, or like, yeah?
You group x cubed minus y and 5y's.
There's no y.
Oh, sorry.
X cubed minus x, you mean?
5x squared minus y.
Yeah, by the way, when you group them, what property are you using? You're using the associative property of addition. This case, if you didn't do it, it's fine. But then when you use associative property, does it only work for addition or does it also work for subtraction? Only works for addition. Guess what I'm going to do to be safe? I'm going to make everything to addition, guys. This case, it didn't really matter, but sometimes it will. Especially if right here, if this thing was negative. You know what I'm talking about? Hello? Okay, if this was negative, if you just blindly put the parentheses around, you're going to get it wrong. So make sure you change it to everything to addition if you want to be safe. Okay? But this case, it didn't matter. Anyway, do I have any common factor then? Well, not yet. I got to factor out my GCF from each of these two binomials, right? Derek, what's the GCF for the first two terms?
For the first two terms, it's x.
X. What about the last two terms? John, what's the GCF for the last two terms? 5. John, tell me what to write. So y times, when you factor out the x, you get y times x times. Huh? No, the first two terms. When you factor out x, what do you get? Times x? No, you got x cubed plus negative x. When you factor out the x from there, what do you get? X times what gives you x cubed plus negative x, in other words. Right? We're using distributive property backwards here, right? Right, John? Do you see this binomial, John? You got x cubed plus negative x. Let's factor out the x, right? That's a common factor. What do we get? X times what gives you x cubed? X times x cubed gives you x cubed? X times, come on, you know this. X times what gives you x? X cubed means x times x times x. So x times what gives you x cubed, John? Okay, don't help him, he knows. Okay. X times x. X squared, right? Don't we get this? X times x squared plus negative 1? And then plus 5 times x squared plus negative 1? Okay, good. Now, are we done? No, we have a what? Well, we don't have difference of squared.